Hi everyone, in this example we are going to make an investigation about a claim made by Nike about their new golf ball. Nike claims that the Nike brand golf balls are better than Titleist's golf balls, and we are not going to believe that, right? As statisticians we are going to make an investigation. Running a hypothesis test, it is very important that you clearly define and understand what the parameter of interest for that particular hypothesis test is. In this case, we are making an inference about the population mean. The unknown population mean, mu here, is the average drive length with Nike balls. And that is the parameter of interest. Next step is to form the null and the alternative hypothesis, right? So what would be the null hypothesis? How would you form that null hypothesis? Can I give one quick second for you to write down the null hypothesis here? Yep, you got it. So the null hypothesis here is that mu is equal to 208, which we know that Titleist's ball has an average drive length of 208 meters, and the alternative hypothesis is, following the claim made by Nike, the alternative hypothesis will be to test if that mean, the population mean, is greater than 208. And based on the alternative hypothesis here, you will agree with me that we are running an upper tail test, right, as we learned in the class and in lecture 13. So what other information have we been given to answer this question or to do this investigation? You have been given a sample of 100 drives that a golfer made from Nike balls. So this is the sample that we have, and a sample size is 100, and the data, let's assume that the data are given to us, and these are the distance from each of the Nike balls, and then there will be 200 observations here, and I have calculated the mean, sample mean, and the standard deviation for the drive length. They are 209.45, and the standard deviation is 12.158. To run the hypothesis test, you now need a test statistic, right? How do we calculate the test statistic? For a test statistic will be a t-test statistic. We have discussed why we are running a test statistic, t-test statistic, in lecture 13. It will be equal to x bar minus mu. Mu here is the average drive length with a Nike ball, and s divided by s the sample standard deviation, and you divide it by square root of n. So, and you all know that we calculate this test statistic assuming that the null hypothesis is true, right? So what we have in the null hypothesis is that mu is equal to 208, right? So we calculate the test statistic with the information available to us. We know that x bar is 209.45. It is from the sample data we have, and we know that then the mu is 208, assuming that the null hypothesis is true, and the sample standard deviation is 12.158. You divide it by square root of n is 100, and you know that the denominator, we have another name for this denominator. What is it? Yep, standard error of x bar. Excellent. Now the t-statistic we calculate using all this information we have, therefore, is 1.193, right? So we have discussed that if this t-statistic, given that we are running an upper tail test, if this t-statistic falls into the far end of the upper tail, we would say that this test statistic looks like it's not coming from the t distribution, Tn-1 distribution. Therefore, we will reject the null hypothesis. If this test statistic do not fall into the far end, we would say that this test statistic looks like it is coming from Tn-1 distribution. Therefore, we will not reject the null hypothesis. We need to have a decision rule to see how far this test statistic fall into, right? And we have learned that we can have two different types of decision rules. One using p-value approach and the other using the critical value approach. And before we move on, we also have to notice that what level of significance we run this test. It is given in the question that we are running the test at 5% significance level. Alpha, therefore, in this particular case is 0.05. So what this shows us is an upper tail test decision rule at 5% significance level for a Tn-1 distribution, right? So the area here, the blue area here is the alpha value, alpha level, the probability, which is 0.05, and that we have learned that if the calculated t statistic fall into any above this area here, right, so which is highlighted in the red line here, we will reject the null hypothesis. And if the calculated t statistic fall into the area where highlighted in green line, we will not reject the null hypothesis. So we have the rejection region, and this is the non-rejection region. Let us focus on p-value approach first, right? Then we can go and look at the critical value approach. We use the calculated t statistic to calculate the p-value. We have learned to do that using Excel, right? So to calculate the p-value using Excel, we need to know the t statistic that we calculated using sample data. So our t statistic is 1.193, and knowing that we are running a right tail test or a upper tail test, we can directly get the p-value from Excel, telling Excel that, hey, we are running an upper tail test, right? To do that, you have p equals t dot, like the equation that you write in Excel, of course, is t dot dist dot rt to say that this is a right tail test or an upper tail test. And then you provide the t statistic calculated, which is 1.193, and the decrease of freedom, which is n-1, n is 100, n-1 therefore is 99. Excel directly gives us the upper tail p-value. If you ask Excel to calculate it using this equation here, so that in that way you don't have to find the 1 minus alpha p-value and then deduct it by 1, right? You can directly work out the p-value this way with the RT command. So the p-value that we got from the Excel with the t statistic 1.193 we have is 0.118. In the graph, we can draw it like that. Our t statistic is 1.193. So this area here is the p-value, which we can denote in notation form that the probability in Tn-1 distribution, which is greater than the t value. The t is the calculated t value, which is 1.193, and this area is 0.118. Do you remember what our decision rule in this particular case is? Our decision rule is to reject H0, right? If p-value is less than alpha, which is equal to 0.05. Now we have to look at the p-value that we calculated, which is this, and see if it is less than alpha 0.05, and then make a decision based on that value. Okay, the p-value that we got for this test, which is 0.118, is greater than alpha, which is 0.05. If I draw this alpha value in this particular example, alpha equal to 0.05 should be something like this, right? And the p-value is obviously greater than that alpha value. Therefore, our decision would be to reject H0, right? Let's now go on and make the conclusion. We know that the p-value we calculated, which is 0.118, is greater than 0.05. Therefore, we do not reject the null hypothesis. It's very important that you make a conclusion based on the what you did in the hypothesis test. The research question, or the question asked from us, was whether we have sufficient evidence to say that the Nike's claim is correct. Under that question, we formed the null hypothesis to be mu equals 208. The alternative hypothesis was that mu is greater than 208, meaning that we did not reject the null hypothesis against the alternative that mu is greater than 208. We can conclude that the evidence did not support the Nike's claim. Okay, that's how we made the conclusion, or we arrived at a conclusion based on the p-value approach. How would we go with the critical value approach, or if we used critical value approach, or if you were asked to use critical value approach instead of the p-value approach? You all have learned now that either approach you get, you should arrive at the same conclusion, but for the sake of understanding and learning, let's go and do the critical value approach as well. So in the critical value approach, what we do is to have the rejection region based on the critical value, right? So you look at the alpha value, which is 0.05, and then we find the t value corresponding to this probability, right? And then we compare that t value, which is known as the critical value, with the calculated t value we have in the question. So the rejection region and the non-rejection region doesn't change. Everything else remains the same. The only difference here is, rather than looking at a p-value, which is relevant to the t statistic we calculated, what we do here is to find out the t value corresponding to this probability here, right? So let's see how we do that, right? We again use Excel to find that probability, find the critical value. And you know that in Excel, for you to find this particular value, or this particular t value, you had to look at the cumulative probability on the left side. You had to tell Excel that what that cumulative probability is, and then Excel finds this point, like this t statistic or t value for you. So when alpha is 0.05, the rest of the area is 0.95, which is 1 minus 0.05. And we tell Excel that if for the sample size of 100, we have the critical value can be found using t.inverse function, t.inverse, and then give the cumulative value from here up until that critical value, which is 0.95, and then the degrees of freedom, which is 99, because our sample size is 100. And that critical value, as Excel finds, is 1.6604. Right, now you compare this value with the